Welcome to this video on our universe. Our aims are to find out more about the solar system and the universe it sits within. So the solar system can be modelled as planets which rotate on tilt axes while orbiting the sun. That means basically going in big circles around the sun. The planets often then have moons orbiting them. We have one moon, but other planets have more than one moon. Sunlight spreads out and is reflected, and this explains days and years and seasons. So, how do we see other bodies in the solar system? Well, the sun is a star, and that's a luminous object, which means it gives off its own light, that it produces itself. Other objects in our solar system, moons, planets, comets, asteroids, they are not luminous. That means they don't produce their own light. So the way that we see them is by them reflecting the light that has been produced by the sun. So why do we have days and years? Well, day is the time taken for a planet to spin once on its axis. So you can see there that different planets have different length days, some short ones like Jupiter or some long ones like Venus. A year is the time taken for a planet to orbit the sun once. Planets that are closer to the sun tend to have shorter years because they have less far to go to get round the sun once, whereas further away planets such as Neptune have much further to go, so their orbits take much longer. So why are some planets less visible than others? Well, they all rely on reflecting the sun's light. As the light moves away from the sun, it gets spread out. Its energy gets spread out over a wider area. So the further away the planet is from the sun, the less of the sun's energy it will have hitting it. What's more, once that light energy has reflected off of that planet, for us to see it, it then has to get all the way back to Earth. So if the planet is also a long way from Earth, it's going to be even less visible. Okay, so why do we have different daylight hours on different places of the Earth, and why does the amount of sunlight change during the year? So, the Earth is tilted. It's not upright and spinning around the North Pole, straight upright. The North Pole and South Pole are tilted by 23 degrees, and it's spinning around that axis. That means that when the axis is pointing towards the sun, there'll be more sunlight on those parts. So, here we have springtime. The whole Earth is getting 12 hours of light and 12 hours of darkness. As we move round into summer though, or the northern hemisphere's summer, the northern hemisphere becomes more tilted towards the sun, and you can see that everywhere within the red circle is getting a full 24 hours of sunlight, and everywhere else in the northern hemisphere has slightly more sunlight than they have nighttime. As the Earth continues to move around the sun, the axis is no longer pointing towards or away from the sun, it's pointing sideways on, so we go back to having 12-hour day and night. It's an equinox, equal night. So everywhere is the same. As we move then into the northern hemisphere's winter, the northern hemisphere is then pointing away from the sun. So everywhere in that red circle at the top, you see, has darkness for 24 hours a day, and the rest of the northern hemisphere has longer nighttime than it does daytime. While we're in winter though, the southern hemisphere's in summer and getting longer days than nights. And then we move back round into spring again. Now our solar system is a tiny part of one galaxy. We're about 2/3 of the way out of our galaxy, which is called the Milky Way. And light takes quite a long time to travel from the Earth to the sun, let alone across other galaxies. So, how is space exploration affected by this? The universe and the solar system are big, really big. It takes a really long time to get anywhere in space. Now the furthest we've got as a result of that is the moon. But we are planning trips to Mars, and a trip to Mars would take us about a year to get there and back, not counting the time we were on the planet. So those are big long missions. Much easier for those things that are further away for us to send probes. So the furthest we've sent probes out is to the edge of our solar system, and they send information back telling us what it's like at the edge of the solar system. Equally, when we look into space, we're seeing light that left the stars it's coming from millions, billions of years ago. So we are looking back in time as we look out in space. And that's affected how we measure space, because we're seeing things that are happening a long time ago. So we have two ways of measuring in space. We can measure in kilometers, which is 1,000 meters, or we can measure in light years, which is a big number of kilometers. 1 light year is the distance that light travels in 1 year. Now, for light to travel from our sun, it takes 8 light minutes, and that's 146 million kilometers. The nearest star to the sun is 4 light years away, or 40 trillion kilometers. So it's a really long distance. Now, we've just found another planet that we think is orbiting our nearest star. That would take our probes 20 years to get there, and then it would take the information travelling at the speed of light another 4 years to get back to us. Thank you for watching.